Okay, so you guys, that was fun making a circle. Let's make a triangle now. Let's say triangle T1 equals new triangle.
Okay.
Well, it says I can't do that. How come? Yeah, right. I didn't make a triangle class. You can't just go around making whatever you want. Now, if you wanted to, you would just have to make a class called triangle. You would have to explain to the computer what's important in a triangle, like the side lengths and the angles and stuff. Okay? You could put in a constructor. You could make your own class. You could make a rectangle class. You could make a Pokemon class, whatever you wanted. Okay? I got that joke from Mr. Smith. Okay. All right. So you could make whatever you want, but it's not there already. You have to create it. Okay. Now we created a circle class, so we were able to use it. What happens if we print our circle? So if I say system out print C1, okay, or I'll just go ahead and copy that, and I'll do C2. What's going to happen? Let's find out. Okay, compile's fine. Is it going to draw a circle on the screen for me? I mean, that'd be cool. Unfortunately, it's not. Okay. Oops. Oh, by the way, we're going to execute the main method of the tester class. Okay, that's our executable code. That's our client class. All right. Now, if you're trying this, you may have gotten a totally different answer than I did. That's a hexadecimal code that serves as a memory address to your computer. Your computer knows what that means. I have no clue what it means. What it means to the computer is that's in its memory where the information about circle C1 is stored at. Okay? So that's where it's going to keep all of the information on that circle. What its radius is, anything that's available to it in terms of constructors, methods, whatnot. All of that information is available in there. Okay? But otherwise, I don't really know what it means. If I wanted this thing to print a circle on the screen, there's a way I could change this default nature of the print, but we're going to learn that on a different day. Okay. Well, what if I wanted to change the radius of circle 1? Turns out I can. If I tell the computer which circle I'm talking about, I actually have access to its radius, and I can give it a new value. So I could make the radius of circle 1 100. Okay? Just like I'm going to do right here. So if I hit compile, sure enough, there it is. Okay? And to prove it to you, I could print system out print C1 dot radius. Now, notice that I didn't put any parentheses at the end of radius. It's not a method. It's a variable. Okay? The reason I have access to it is there's a couple reasons. One is I didn't make it private. I'm going to in a minute. But for right now, I actually have access to that variable. And I was able to change its radius value to 100. Now that's if you look carefully at this class, this is actually really weird. Nowhere did I say what radius was, or did I declare a variable named radius. So how did the computer know that I even had a variable named radius, and let alone what its value was or how I could store it? Okay. Well, when it saw the reference C1 declared to be a circle, the computer decided if it ever saw C1 again, okay, that it would follow that path over to the circle class and look in there. So it saw C1, it literally followed that path, and it said, oh, well, circles have a double variable named radius used to store amounts in, and that's what it did. It went in there and it actually changed its mind. That variable was 0. Remember, if I did this, if I took this print statement here and put it right here, it would first print 0.0, okay? Then it would change its mind to right here and print 100.0 because I changed it. Well, okay, this is actually considered sort of bad programming, okay? The industry standard is that you're going to make your variables private. Okay, this is called encapsulation. The College Board expects you to make all of your instance variables private. That's called the access control. Okay, so right here, this is called access, and I'm going to make the access private for this variable. Now, here's the effect of doing that. If I hit compile on my circle class, it still compiles just fine. Okay, I'm allowed to use a private variable within its own class anywhere I want. No problem. Okay? But if I go back to the tester class and I say compile, it tells me, sorry, radius has private access in circle. So in other words, I can't do that. Okay? I can't use a private variable from a client class. Okay? I'm going to have to turn that line off. I'm going to have to comment it out. Oh, it tells me the same thing for that one. It's going to tell me the same thing for that one. So I can't use a private variable in a client class. What we're doing is we're preventing somebody from screwing up our program, right? You know, what if they go in and start changing numbers around? Like I said, the College Board expects you to make all instance variables private. On your AP test, you're going to have to write a class. And you're probably going to have to put an instance variable in there. And you want to make sure to make it private or you could lose points. Or they might ask you a multiple choice question about, like, you know, proper code ideas. And they might ask you, I don't know, maybe they'll say spell encapsulation. Probably not, but okay. So that's what this practice is called. It's called encapsulation. Okay? So that's a fancy computer science term we need to know for what this is. Making your instance variables private. That's called encapsulation. Okay. Well, let's say now that I wanted to do some more with this circle. Okay? There's a third component to any good class. It's called a method. Okay? So methods, this is where you put the purpose and function of your class. This is now where we're going to give this thing the ability to do something. So when you guys first learned about circles, you learned about radius, you drew them on paper. One of the next things you probably did was get the area of a circle. So we could make a method that does that process. Okay? So how do we make a method? Well, there's a few parts to a method to consider. First, we consider the access. Okay? Then we consider the return type. Then we consider the method name. And then finally, we consider the parameters. This is called the signature of the method, what I'm writing out right here. Okay? So, the access determines where you can use this method. If you only want the method to be used within this class, you'll make it a private method. Why would we do that? Well, sometimes we do. Sometimes we might have like a really big math function we're going to use over and over, but only within this class. And we'll go ahead and we'll make the method private. Okay. Now, I'm going to make this method public so that I can use it for my client class. Okay, for the return type, this is like, what's the answer going to be? If you go into a math class and you get the area of a circle, you don't say the answer is yellow, okay? So it wouldn't be a string. You don't say the answer is false, so it wouldn't be Boolean. Probably put double here, right? I mean, usually when you get the area of a circle, it's a decimal. So I'm going to say the answer is going to be a double. Method name. You want to name your method Fred? Go ahead. But usually we give it a more descriptive name. So I might call it like get area, or find area, or determine area, calculate area. And then for my parameters, okay, if I have any more information that's required, I'm going to put that information in here. But here's the thing about getting the area of a circle. I only need to know one thing. The only thing I need to know is the radius. Now, there's no reason for me to ask what the radius is because I already know it. It's an instance variable that belongs to this class, and I can use that variable freely throughout this class. So I'm not going to ask the user to tell me what the radius is. They might screw it up. I'm just going to use the one that already belongs here. So here's what I'll do. I'll make a variable called area double, and I'll say it equals math.pi. Remember we learned that earlier? Times radius times radius. Okay? And now, if I hit compile right now, I'm going to get an error. It's going to say missing return statement. When I said that the return type was a double, I was basically promising the computer that I would return an answer before I'm done. I haven't met my end of the bargain. I didn't return an answer. So before I can compile, I must provide a return, and it has to be of type double. Okay? So it's not enough to just calculate the area. I have to return it to satisfy the return type. Now, anyone who uses my method has to satisfy the parameters. For me, I didn't require any parameters here, so I made it easy on the user of this method. They don't need to give me any information. They can just use my method whenever they want. Okay? So on any circle, that is. So now if I go back to the tester, right here, I could actually say like double area equals, maybe I'll take C2, and I'll get the area of C2. And then I could print that area. Okay? So the double that gets returned will be stored locally in area. Or I could just go straight to a print statement too. I could just say system out print C1.getArea. Okay? That would be a different answer. So I can get the area of either circle using this method. And notice how I left the parentheses blank in the middle, right? I didn't put anything in there because this was a parameterless method. Like the length method in the string class, you don't need to give any information. You just need to say which circle you want the area of. Just like in the string class, we say which string we're taking the length of. Now, if you want a substring, then you have to give more information. Okay? There we go. So if I wanted to make a method for arc length, maybe we'll try this tomorrow. You'd have to say how big the arc is, right? Like what's the angle measure? And then based on the radius of the circle, you could generate an arc length. But to do that, you'd have to give more information. How big of an angle are you talking about? 30 degrees, 90 degrees, what? Okay? All right. So there you go. The reason that circle 1's area was 0 was because remember that the default radius was 0, and we lost our ability to change the radius right here.